You can start.
All right. So we'll continue with the importance of soil science in crop production. As I've said earlier, that as farmers, as agricultural professionals, we need soil science knowledge to make informed decisions about our crop selection, our fertilization, our irrigation, and our land management. So, why do farmers need the knowledge of soil science? The first one is to choose the right crop for the soil. There are each soil has different capability. So because of this capability, we need to match our crop requirements with the different soil capability. Also, farmers need soil science knowledge to apply the correct fertilizer because soil contains some basic nutrients. So we only apply fertilizer to boost our crop, and also especially in a situation where there is deficiency of some nutrients. So to avoid wastage, we need to have the understanding of soil science so that we're able to apply the correct fertilizers. Also, to prevent crop erosion by implementing various conservation practices such as crop rotation, mulching, we will prevent soil from soil erosion. And lastly, we need soil science knowledge to increase yield and quality. So we'll move to the next and their effects on crop production. Next slide. Okay, thank you. So we have three basic type of soil. We have the sandy soil, the clay soil, and the loamy soil. Most the knowledge of everyone is just like we only use loamy soil for um crop production. Like that's our basic understanding. But different each soil has crops that can thrive well in them. The first one is sandy soil. So the sandy soil these are some of the basic characteristics of sandy soil. They have low nutrients and drain water quickly due to large particle size. And in this kind of soil, roots vegetables like carrots and crops that are tolerant to droughts can thrive well in sandy soil. And while we are trying to produce crop in such type of soil, we need to add organic matter, use mulch to retain moisture for our crop, and also apply frequent light irrigation because sandy soil does not have the ability to absorb much water. The water drains up easily. The next type of soil is clay soil. The basic characteristics of clay soil is that they hold water too tightly, and this can be hard for root because the roots of a plant cannot penetrate through compacted soil. So once you apply water to our clay soil, it becomes compacted, well, and then making it difficult for roots to extend themselves for crop production. And in this type of soil, we have vegetables that are tolerant to moistures. They can thrive well in this kind of soil. And the last one is loamy soil, which we all know that loamy soil is best for crop production. And why? Because it has balanced water and nutrients. So we'll move to the next slide, which is basic soil properties and why it matters in crop production. While I say basic soil properties is because we have a quite large number of characteristics of soil, but there are some that even as a farmer we need to have the understanding so that we can maximize our crop production. The first one I'll be talking about is soil texture. And this soil texture is just the proportion of sand, silt, and clay in our soil. And why do we need to understand this soil texture? We need to understand soil texture because it helps us to determine our water retention and drainage for crops. And also, this texture affects nutrients availability and root penetration, knowing that different type of soil has their own characteristics. And also, soil texture is very, very important in selecting appropriate crop and management practices, as I've said earlier, because different type of crop thrives in different type of soil. Different soil has different capability. And also the next soil property we should understand is soil structure. Next slide. So soil structure is just the arrangement of soil particles into aggregates, and Why do we need to understand this soil structure? Soil structure matters because it improves water infiltration, the root penetration, and aeration. These are the basic things that the plants need. Infiltration is just how water moves through the soil. Penetration is root penetration, how the roots can penetrate into the soil and absorb nutrients needed for the plant growth. And I want us to note something, that poor structure leads to compaction, poor drainage, and restricts roots growth. In a type of soil where the structure is very poor, it's going to affect our plant because the soil will be compacted, the drainage will be poor, and thereby restricting roots growth. And this soil structure can be improved through some management practices. We can improve our soil structure to suit our plants by adding organic matter, because it's going to break all those compacted soil, and also avoiding working wet soil, and also minimizing tillage. The next slide, please. We move to soil porosity. That's the next soil basic properties we should know. Soil porosity is just the amount of space between soil particles, and this space or pores are the ones that are filled with water and air, and these are the basic requirements for plants: water and air. Why do we need to understand soil porosity? Healthy soil porosity ensures that our roots get both air and water, and also it's it leads to poor aeration and drainage if there is no much pores in the soil. Like if the pores are compacted, it will lead to poor aeration. That means air will not be able to pass through our soil, and it's not ready for our plants, and also poor drainage. We move to the next soil properties, which is bunk density. This bunk density is just compact the soil is how compact the soil is. Basic definition of bulk density is just the mass of dry soil per unit volume, and it has some calculation in it. But this bulk density, we need to understand it because it helps our root growth. When the bulk density is too high, it's going to restrict our root growth, water movement, and nutrient uptake, because if the bulk density our soil is compacted and is not suitable for our crop production, because it's going to hinder our roots from growing, it's going to hinder water from moving in from our soil, and it's going to hinder nutrient uptake by the plant. So we'll move to the next one, which is soil pH. Soil pH is just shows how acidic or alkaline the soil is. I believe that everyone should just know the importance of soil pH, because I feel different plants has um the pH that they thrive with in them. So why does pH matter? pH matters because it affects our nutrient availability. When the pH is wrong, nutrients become locked, and soil become locked in the soil. That's when the pH is wrong for the plant. The plant will not be able to absorb the nutrients, and these nutrients will not be available to our plants. And also when it's present in adequate amounts, it's okay for our plants. Then we can manage this soil acidic. That means we can correct them. In case the soil is too acidic, there is a way we correct them by applying lime. If it's alkaline, you can treat it by adding organic matter. pH can actually be corrected to suit our plant's crop, but looking at it is going to increase our cost of production. So it's better we just understand the pH and work with the crops that can thrive in that kind of pH. The next one is soil nutrients. Yes, the soil itself has the nutrients in it. Even before we apply our own fertilizer, the soil has its own nutrient, and these nutrients is divided into two. We have the macro and the micro. The macro are the ones that are needed in large amounts, while micronutrients are just needed in small amounts. Why do we need to understand our soil nutrients? You know that nutrients affect our growth. It affects the growth, it affects the flowering, it affects the fruiting, and it also affects the yield. So we need to understand the nutrients that are present in our soil, so that we'll be able to know, like I said earlier on when we were discussing why do we need to understand soil science. So you need to understand this soil nutrients so that you know the right amounts of fertilizer to apply to your soil whenever you are planting. The next one is calcium exchangeable capacity, which is the ability of the soil to hold and exchange nutrients. So why does this matter? It matter because the soil exchange capacity helps to retain nutrients better and help us to reduce fertilizer loss. When we understand this one, we know the right we know the time to apply our fertilizer, the right fertilizer to apply to prevent loss and also to prevent wastage. And this exchange capacity can also be corrected. If it is low, we apply a smaller fertilizer, and when we want to increase our cation exchange capacity of our soil, we increase it by adding organic matter. So the next one is the soil organic matter. Soil organic matter is it consists of decomposed plants and animal residues. That's the waste that are coming from our plants and our animal. So this soil organic matter might be in form of a fresh residues of plants, which are leaves, roots, or crop remnants. Also, partially decomposed materials and humus, which are fully decomposable organic matter. That means after all these our leaf roots are decomposed, like they have decomposed completely. That's what we call humus. Why do we need to understand the soil organic matter? Because soil organic matter helps to improve our soil structure, also increase water holding capacity, it supply nutrients, and it supports microorganisms. That's just the basic importance of soil organic matter. The next one is soil microorganism. So soil microorganism, they are just how do I okay, soil microorganisms include bacteria, fungi. They are tiny organisms that lives in our soil, and their basic work is just to break down nutrients to absorbable form by the plant, like to break it down the the units whereby the plant will be able to absorb it easily. And this soil microorganisms include bacteria, fungi, protozoa, and all others. So why do we need to understand soil microorganisms? They help in nutrient cycling, like I said earlier, they help to release nutrients in available form to our plants. Also, organic matter decomposition, yes, they help to convert all these corporate residues into nutrients, and also improve soil structure because they help to bind soil particles together. They have to bind soil particles together. Then the next slide, where we'll be talking about soil management practices for sustainable crop production. What are the management practices we are to um, employ to our soil to ensure crop production? The first one is soil fertility management. The proper use of organic and inorganic fertilizers to supply essential nutrients. Like we need to manage our soil properly through soil management facility so that we know this is just like knowing the type of fertilizer to apply at the right time and and when to apply them. So this is what soil fertility management has to do with. And what are the key practices in this one? This involves soil testing. We need to carry out our soil test before, maybe after some time, after we have produced our crop for quite a number of time. We need to test it to check the availability of our nutrients and also to check the pH. The next one is balanced fertilization. We have to apply our soil nutrients based on our soil test results. After carrying the soil test, you already through that soil test, you will know which of the nutrients are absent, which one is too much, then you'll be able to correct them and balance it. The next one is through organic amendments. That means you know when to use compost, manure, crop residue, and all of that. And also timing and placement. This is just applying the fertilizer at the right time, at the right place for the roots to maximal efficiency. And what are the benefits of this soil facility management? It just helps us to apply the nutrients correctly to optimum crop yield and prevent over fertilizer, which wastes money and also pollutes our water and our soil. And also to prevent under fertilization. We move to the next management practices, which is soil conservation practices. Conservation just means practices that protect our soil from erosion and degradation. What are the key practices we employ in these soil conservation practices? The first one is mulching. That means this is covering our soil with organic materials like straw, leaves, and also reducing soil erosion and to retain moisture in our soil. The next conservation practices we can employ is cover cropping. We can plant cover crops on our plants. The next one is grass strips. That means we are planting grasses barrier to this is to filter sediments, like to remove some unuseful material from our soil. And also we have contour farming, which is planting along contours and slopes. That's for slopy lands. And why do we need to do these conservation practices, which are the benefits? This one help us to maintain our soil structure, reduce nutrient loss from erosion, and also remove the most fertilized topsoil, whereby reducing productivity. And conservation practices does not only protect our soil, they prevent sediment pollution. Yes, they help us to filter sediments from our soil and nearby water bodies, because we know soil and water are related. Then the next soil management practices is soil water management. This is managing soil moisture through proper irrigation, proper drainage to ensure optimal water availability for our crop. So what are the key practices in this soil water management? The first one is proper irrigation. We don't just wake up out of the blue moon and just start um applying water to our soil. We need to apply water based on the crop needs and soil moisture status. And the next one is efficient system. You know when to use. You know we have different type of irrigation method. We have drip irrigation, we have sprinkler, and all of that. So when we understand this soil water management, it helps us to make decision on the kind of system we are going to be using on our land. Maybe it's drip or sprinkler, and this helps us to prevent water waste. The next one is drainage. You know when to install drainage system, especially in soils that are poorly drained. And the last one is mulching. This is just like to maintain constant soil moisture. This is when we cover our soil with fresh leaves and all other materials. And why do we need to do this soil water management? Because we need to do this one because proper irrigation and drainage ensure adequate moisture for our crop. That means we'll not be applying too much water, we'll not be applying less water, and this helps us to prevent some other problems like waterlogging. That's when there is too much water in our soil, and also drought stress, because it's not um advisable, it's not favorable to our plants when there is drought stress, I mean. And the last one is to improve soil organic matter. So increasing organic content of the soil through addition of plants and animal materials. This is how we improve our soil organic matter. And what are the key practices in this place? We apply compost application. Compost is just a form of fertilizer. And the next one is manure incorporation. That means we can use all these cow dung, poultry manure on our plants. And also crop residue retention. We can leave our crop stakes, leaves, so that they will get decay and thereby increasing the organic content in our soil. And also we can reduce tillage. Tillage is just this use of machines to prepare our land. So we can reduce them, minimize. This is just to minimize the disturbance of our soil and to prevent organic matter decomposition. What are the benefits of improving soil organic matter? By adding all this compost, manure, and crop residue, we improve our soil quality in multiple ways. And this helps us to increase soil structure, increase the water holding capacity, provide slow nutrients, and also stimulate beneficial microbial activities. And in conclusion, soil science just provides the foundation of successful crop production. When we understand all these basic soil properties that we have listed above, such as soil texture, soil structure, box density, soil porosity, pH, it enables farmers and agronomists to make informed management decisions. I mean, we not just decide on our own. When we understand all this soil science, we'll be able to make decisions that will improve our plants, support, and even prevent us from wasting our resources. And what are the key principles that we just need to put in place in this place? The first one is just to test our soil. Soil test is very, very important. After soil test, you already know what you have in your soil. You already know the condition of your soil. The next thing is to match the crop with what your test is saying, with the soil capability that you have as a result of the test that you have carried out, is to match your crop. The next one is employ all these management practices to prevent our soil um, from soil erosion and all other things. And also, this soil science help us to apply nutrients. Just wake up out of the blue moon and know that I'm going to apply NPK at this. No, so understanding soil science help us to know the kind of nutrients that we need to apply at a particular time to prevent guesswork. And the last one is, by applying all the soil science principle, we can achieve higher yield, reduce input cost, yes, protect our environment, especially our soil and our water, and also ensure long sustainability in our farm operation. Yes, we'll be able to ensure sustainability, knowing fully well that we are producing our crop directly from the soil. And that will be all. I'm done. And the last slide is, I don't know if anyone has question um and any other addition to add. Thank you.
Okay, thank you very much, Miss Victoria. Thank you very, very much for that very insightful session. Thank you so, so much. I believe we've gained clarity, we've gained a lot on this session. At least if not for anything, um, I think production, we should know now that production has moved from when farmers just wake up and decide to plant without even checking their soil structure, the type of soil they have, and all that. So, thank you so much. So, is there anybody that has any question? If you have any question, please raise your hand so we can take the question. Anybody? Anybody? Feel free to ask your question. I'm sure Miss Victoria is more than willing to answer.
Hi. Hello.
Okay. Yeah, we can hear you.
Okay. Good evening, Miss Victoria. So, thanks so much for
Mm.
this wonderful presentation. So, I just want you to shed more light. I know people knows about pH very well, but I just wanted to shed more light on the pH aspect. Yes, just go maybe deeper. I don't know, not really deeper, but at least to some extent to this is understand.
Okay, thank you. So, like I said during the course of the class, I said pH is just help us know the condition of our soil. Maybe it's too acidic or it's too alkaline. And this pH actually range from um 1 to 14. 1 to 6 is acidic, while the other one is alkaline. That's 8 to 14, while 7 is neutral. And different plants have the pH, like different plants thrive in different soil pH. I think that should be in, I don't know if it's been taken in crop production, like maybe there's a session where they'll talk about the basic requirements for different crop. So during the course of that, you will see where um different plants has the pH where they strive in it. So you'll be able to match that with the pH of your soil. Maybe for tomato, I'm not really sure about it. Maybe it's 5.7 and your soil pH is telling you 5.7, your soil pH is telling you maybe like 8. Although there's a way you can correct it, but if you have other um options, like there are other crops that you can plant that that align with that pH, it's better you go for it, although pH can be corrected. Like I said, I said if it's too um acidic, you can add lime. If it's too alkaline, you add your organic matter, and I think they used to add sulfur too. Yes, they add sulfur too to it. So I don't know if that's okay by you, Mr. Tim.
Yeah, that's fine. It's okay. Thank you so much. Thank you so much.
You're welcome.
Okay, thank you so much, Miss Victoria. Is there any other person that has a question? Any other person? If you have a question. Okay, Mr. Ogaga, I can see your hand. Please ask your question.
Okay, so thank you, Miss Victoria, for this insightful class. Thank you so much. So the my question is with respect to cation exchange capacity. Can you like share more light on it that the listeners can understand what CEC mean? Thank you. Hope you heard me.
Yes, I can hear you. So from the CEC, that's cation exchange capacity, we know cation are charges that are present, and exchange is just like movement capacity. That's this ability of the soil to move these charges, like to move these charges, because cation are actually positive charges. Sorry. So this is just telling us how soil can hold positive charge nutrients, and also how it can move them, like exchange them, like break them down to available form for plants. So, and it can also be corrected. Yes, it can also be corrected. I don't know if that's okay by you.
It's fine. Thank you so much.
Yes, sir.
Okay, thank you once again, Miss Victoria. Is there any other person that has a question or contribution?
Okay, for the CAC, can you hear me?
Yes, sir.
Yes.
So my own
Yes,
contribution to that CAC is more like the amount of nutrients that your soil can hold. You understand? So if I higher CAC, it means you have more nutrients in your what's called in your soil. So it means the way the way the roots of plant is able to uh, tap nutrients. Do you get? So there's something they call a colloid. So that colloid, that's where your nutrients is, they attach to it. So it's more like you exchanging. Your root is exchanging. So there is hydrogen at the root tips. So the more, if there is no nutrient in the soil, it means there's going to be more of exchange of hydrogen. So that's why most of the time you have acidic soil. Shey you get? So your plant cannot exchange. There's nothing in the soil that your root can exchange with. So that's it. That's what I can just say to the Kata instinct.
alright, thank you very much, Mr. Jimmy. Thank you so much. Does any other person have any contribution? Okay, so in the absence of more questions or contribution or any suggestion, we can call it a night. We're not calling it a day. We can call it a night. Yeah. So thank you very much for joining class, and good night, everybody.
Good night.